Hello, everyone. You were just looking at a piece of polar graph paper that I made myself to do a unit circle in. The unit circle is a thing that's highly symmetric so that once you've worked it out one time, you can probably memorize the pattern pretty well. And when you memorize the pattern, it allows you to know the special angles or the trig functions evaluated at the special angles being 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 6, 5 pi, or 3 pi over 4, excuse me, 5 pi over 6, pi, so on and so forth. So basically all the 30s, all the 30-degree increments and all the 45-degree increments plus 0, 90, 180, and 270 in degrees are plus 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, and 2 pi radians. So it basically just gives you a little bit more familiarity with the trig functions. We can go after this, we can go through and start making graphs, for instance, of the sine of theta, the graph of the cosine of theta, the graph of tangent theta, and then of course you can use those same points because remember cotangent theta is just 1 over tangent theta, and secant theta is just 1 over cosine, and then cosecant theta is just 1 over sine. So you can actually get all 6 of your trig functions and know them quite well. So I'm going to work out, first off, I'm going to take this blank polar graph that you saw, and I'm going to label the actual degrees and radians so that you'll know what they are. And then I'm going to use that to derive the coordinates of the actual points where the radial lines touch the unit circle. Now remember, this is a unit circle, so the radius is supposed to be 1 unit long. That makes it nice because when you take, for instance, the sine of theta, you get opposite, which would be y over hypotenuse, which is always going to be 1. So generally speaking, at least on the special angles of 0, pi, or 0 pi over 2, pi, 3 pi over 2, and 2 pi, you can treat x coordinate as if it's the sine of theta, and then you can treat the y coordinate as if it's the cosine of theta. So that actually works out really nicely. But I'm going to use smaller angles, I'm going to stick to the 30, the 60, the 45 to figure out all the interval angles and the angles in between in each quadrant. So it's just a little nicer because we can look at a triangle that we've memorized, the 30, 40, or excuse me, the 30, 60, 90, which is also the pi over 3, pi over 6, 90, and the pi over 4, pi over 4, pi over 2 triangle, or the 45, 45, 90 triangle. So let's turn over to my cool unit circle graph I made, and let's start working. So I've actually made it a little bigger than I wished I had. I thought it was would all be able to fit in one screen, but it clearly can't. So we'll work out the top half, and then we'll you'll have a backup of that. And remember, you can always get these by emailing me at Billy, BILLY, at physicssolutions.com. That's PHYSICSSOLUTIONS.com. So here we go. First off, we know this angle is going to be 0 radians, and actually this is the only time I'm going to write radians. Everything else I'm just going to put a pi in there. And actually I don't think that blue shows up too well, nor do I think it's very well focused, so I'm going to write that back in black. The 0 radians on this line, it's also 0 degrees. Now if you notice, I know that 2 pi is all the way around, so I can also call this 2 pi and 360 degrees. So they're one and the same, basically. 2 pi and 0 radians, 360 and 0 degrees are essentially the same thing. So now if I look at that, if this whole way around is 2 pi, then we know this halfway around is pi. And of course, that's also equal to 180 degrees. So I'll write it like that. Now we've got that, and what I realized, if I ignored this line and this line, which are my 45 degrees, you can see that this is one pizza slice, this is one pizza slice, this is one pizza slice, there's another, another, and another. It tells you there's 6 pizza slices in pi radians, so clearly this is pi over 6. So I'm going to say this is pi over 6, which is also equal to, if you divide 180 by 6, you get 30 degrees. Again, I'm going to jump to the next pi over 6 because this is pi over 6. Then I jump another pi over 6. That's 2 pi over 6, which becomes pi over 3. And of course, if you divide 2 pi over, well, let's just take it like this. If you basically just say twice of 30, you get 60 degrees. Of course, this is pi, and that's 90 degrees. Excuse me, pi over 2, and that's 90 degrees. Because I can tell, again, this is one and this is one pizza slice. So there's two of these size pizza slices in here. So that's why I know I divide pi by 2 to get this angle. Now this is, of course, pi over 2 plus another 30 degrees. I want to make use of that because when I go to actually evaluate what the coordinates of this point is, I'm going to treat the angle right here and not pay any attention to the fact that it's actually 90 degrees bigger than that. But in principle, this is pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, which equals 2 pi over 3. So I'm going to say this one's 2 pi over 3. But I also know that 2 pi over 3 is basically 90 plus 30, so that's 120 degrees. Okay, jump to the next. This is 4 pi over 6, so this one's going to be 5 pi over 6, and this one will be 6 pi over 6, which makes sense as well. But this one's going to be 5 pi over 6, and that doesn't reduce, so we just call that 5 pi over 6. And that, of course, is equal to 90 plus 60, which is 150 degrees. Now we've already evaluated the pi over the pi and the 180. That's 6 pi over 6. This would be 7 pi over 6, and that doesn't reduce either, so I'm going to write it as 7 pi over 6. And of course, you can see that's 180 plus 30, so that's 210 degrees. Again, skipping the 45, I go to 7 pi over 6. This is 8 pi over 6, and 8 pi over 6 can be reduced to 4 pi over 3. So I'm getting near the bottom, so I'm going to move it up a little bit so we can at least evaluate the angles. That's 4 pi over 3. Of course, this is also 180 plus 60, and 180 plus 60 is 240 degrees. Now that we have that, we can go to, in fact, 9 pi over 6, which 9 is 3 times 3, and 6 is 2 times 3, so the 3 will cancel out, and it'll leave me 3 pi over 2, which is what we already knew. 3 pi, well, I should write this in here. 3 pi over 2, and that, of course, is 270 degrees because it's 3 times 90. So we'll ignore this for right now. Might be able to make use of it in another symbol. All right, when I go back over here, I'm now going to go another theta degrees. So this is another 30 degrees. I'm going to use that too to evaluate this point, just like I will use probably this angle to evaluate these points. But this one I happen to know, this was 8 pi over 3 over 6. This is 9 pi over 6. This is 10 pi over 6. And of course, 10 pi over 6 is the same thing as 5 pi over 3. I don't know why I keep writing it down there. Of course, that's also 270 plus 30, so it's 300 degrees. Skipping the 45 again, I get to 10 pi over 6, 11 pi over 6, and 11 pi over 6 doesn't reduce. And that's also equal to, of course, 270 plus 60, that'd be 330 degrees. Now I'm going to go back and hit the 45 degree angles. So the 45, of course, which is 1/2 of 1/2, so that's clearly pi over 4. But that's also 45 degrees. This is 2 pi over 4, which gives me pi over 2, and this is 3 pi over 4. So 3 pi over 4, that doesn't reduce. I write 3 pi over 4, and of course it's also 90 plus 45, so that's 135 degrees, which is consistent with this being half of the 30 degrees. So if you just added 15 to that, you get 135. You add 15 to that, you get 150. So now we can jump to, that was 3 pi over 4. This is 4 pi over 4. This is 5 pi over 4. Again, 5 pi over 4 doesn't reduce. And I'm getting close to the bottom of the paper again. So I move the paper back up. So this is 5 pi over 4. And of course, it's also 180 plus 45. So that's 225 degrees. And then this is 6 pi over 4, which reduces to 3/2, and then 7 pi over 4, which again doesn't reduce. So that'll be 7 pi over 4. And of course, that's 270 plus 45, which would be 315. So 315 degrees, which is again consistent with this being 15 degrees between them. So we've got all the angles worked out. Now it's just a matter of working out the actual coordinates. To do so, we want to remember our triangle. If you don't already have the figures already worked out in your head and memorized, then you want to be able to draw on the triangles. So let me just draw the triangles up here for the heck of it. So I'm going to put the triangles over here. I'm going to put the 30, 60, 90, and I'm drawing it roughly. It's not going to be perfect, of course. So that angle looks a little bigger. This angle looks a little bigger. So this one's going to be opposite the square root of 3. This angle is going to be opposite the 1, and this will be the 2. And this, of course, being the bigger angle, is pi over 3. And this is pi over 6. And then over here, we also have the other special triangle. And this is 1 square root 2. This is pi over 4, as is that angle over there. So we can use that over and over again. So when I look at this first angle right here, I see the angle is in fact pi over 6. And what I want to do is find out what the x and y of this point are. So I want the x comma y. Now you can see, if you imagine this triangle right here, let me draw it with a blue line just for reference. This triangle right here gives us sort of the whole deal. What it tells you is if I take the sine of theta, I'm going to get y over the hypotenuse. So the hypotenuse is 1. So if you solve for y, you just get y equals 1 times sine theta. So that tells us something that we're going to use over and over again, and that is y is equal to sine of theta. That's going to be true for all these angles, and I'm going to make use of it at 90 and 180 and 270, or at pi over 2, pi, and 3 pi over 2. The other thing is if you take cosine of theta, you get adjacent, which is x over hypotenuse. And again, the hypotenuse is 1, so we'll say x is going to equal cosine theta. Again, that's true for all of them, but I'm going to use the smaller angles when I'm actually deriving the points. But if I need the sines, this would actually give it to you. So with knowing what coordinate, what quadrant you're in. So with all that, we can now start up doing this triangle. So I know the x is going to be basically the cosine of pi over 6. The cosine of pi over 6, you can see, is root 3 over 2. So this answer is going to be root 3 over 2 for x. And then, of course, the sine of pi over 6 is just 1/2. Again, as you can see there, so that's just going to be 1/2. Now, once you get this first quadrant worked out, there's a lot of symmetry between here, so you can help yourself remember those numbers just by that. But it's really useful to go one time through this, doing it this way. Again, the y is going to be the sine of theta. The x is going to be the cosine of theta. We're doing cosine of 45 for x. And of course, cosine of 45, as is the sine of 45, is 1 over the square root of 2. But we call that square root of 2 over 2. So it should be the square root of 2 over 2, comma, square root 2 over 2. And of course, that's also on the line y equals x. So you'd expect that to be exactly y equals x. Now this one's going to be of 60 degrees, and again the x is the cosine of it. The cosine of 60 is actually 1/2. So I want to say this coordinate is 1/2, comma, and then the y is sine theta. The sine of pi over 3, you can tell, is root 3 over 2. So this one's going to be root 3 over 2. I'm getting on the messy part of the paper. Now we already know what this coordinate point is. You can tell it's x equals 0, y equals 1. So it's 0, 1. And that also tells you, remember, y equals the sine of theta. So the sine of 90 degrees must be 1. X equals cosine of theta. So the cosine of 90 must be 1 as well. So it's the sine of pi over 2 is equal to 1. And the cosine of pi over 2 is equal to 0. So all of these will help us in graphing. Now, to do this next part, I could, try to work out the details of what kind of triangle it would be with its 120 degrees, which is, of course, 2 pi over 3. But it's a lot easier to just examine this triangle right here and realize in this place, this is actually the sine of theta would be opposite, which is the negative value of y over the negative value of x over the hypotenuse, which is 1. So this value over here says that negative x is equal to sine theta. So in this category, we're going to say x is equal to negative sine theta, and y is going to be cosine theta. Notice I don't have to put a negative in there because it's the same direction, because we're getting out only positives by dealing with 0 to 90 degrees. So by dealing with 0 to pi over 2, all the angles are positive. I mean, all the results of the trig functions are positive. So, and you'll know that also when you see the graph of sine and cosine. So in this case, I'm now going to say, okay, well, I want the sine of pi over, remember this angle is just pi over 3, or pi over 6, excuse me. So now I want the sine of pi over 6. Well, the sine of pi over 6 is just 1 over root, 1/2. So this one's going to be negative 1/2. So I now know the x coordinate is negative 1/2. I should probably write that in black again. The y coordinate is cosine of pi over 6. And the cosine of pi over 6 is root 3 over 2. And I think you see that is exactly, these two are symmetric with respect to each other. One's shifted 30 degrees that way, the other one shifted 30 degrees this way. So you expect their heights to be the same, 1/2, root 3 over 2 and root 3 over 2. And you even expect their shift this way to be the same as their shift this way. In other words, going from this line to here should be the same number as going from this line to here. So they both should have a magnitude of 1/2, but this one should be negative because it's in that quadrant where the x-axis is a negative. So all these x values all the way from the origin this way are all negative. All the y values on this whole top half are all positive. So that'll flip when we get over here. So I'm basically temporarily using the fact that this is pi over 6 instead of having to deal with the bigger beast, which is the 2 pi over 3. But it still gives me the right results. I now know, for instance, that the using the original assumption, x equals cosine theta. So I know that the cosine of 2 pi over 3 is negative 1/2. And the sine of pi over 3 is positive, or excuse me, of 2 pi over 3 is positive root 3 over 2. So remember, these are our fundamental results, and but the little angles I'm putting in here and all that, those are just special ones that allow me to get the magnitudes and then I have to correct for sine. So now I go to this point. This is another 45-degree angle. So I'm looking at it now and saying, okay, well, that was pi over 6. Well, this one right here is pi over 4. Like so. So I got this triangle. And of course, again, the x is the negative of the sine theta. So I want the sine of pi over 4, which is root 2 over 2. But it's got to be the negative of that. So it's negative square root 2 over 2. And of course, the cosine is the same thing. And that gives us the y. And that's the square root of 2 over 2. Again, notice how symmetric that is. Root 2 over 2, root 2 over 2, root 2 over 2, root 2 over 2. The only difference is, again, this x has to be negative over here. So once you've got this first one, you can sort of figure out what all the other points are going to be. And you'll see that when I drop to the third quadrant as well. Now, 5 pi over 6, that's a whole different beast. But remember, this angle right here, which forms a triangle, is actually just pi over 3. So I can do my work with the triangle that's formed here, pi over 3. So with pi over 3, again, I notice that the sine gives me the negative x. So the sine of pi over 3 is actually root 3 over 2. So I need to make that negative root 3 over 2 because it's in this quadrant. And then, of course, the y would be cosine of pi over 3. And the cosine of pi over 3 is 1/2, as again, you can tell from that little triangle. So I now have all three of these points. Again, I'm going to go back to my y is sine theta and my x is cosine theta to get this. And I just realized that, of course, the x now has a value of 1, negative 1, and the y has a value of 0. So this is negative 1, 0. And since x is equal to cosine theta, the cosine of pi must be negative 1, and the sine of 0, or excuse me, the sine of pi must be 0. So that's what these coordinates are giving me consistently. This is cosine, 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 this is cosine. And then this is sine, 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 and this is sine. So now we just repeat that process. Again, I have a pi over 6, making yet another triangle. This triangle is going to look like this. I'm going to have in this case, sine equals opposite over hypotenuse. So we're back to sine is equal to the y value, and cosine is equal to adjacent over hypotenuse. And of course, the cosine is equal to, in this case, the negative of x. So x is equal to negative cosine, and y is equal to negative sine. So now all I got to do is say x is equal to negative cosine, and y is equal to negative sine, and just take the cosine and sine of these. Of pi over 6. Well, from the triangle, I know that the cosine of pi over 6 is root 3 over 2, and, or excuse me, of pi over 6. Cosine of pi over 6 is root 3 over 2, and the sine of pi over 6 is 1/2. So x is equal to the negative cosine, so that gives me this coordinate point right here. Should be x is equal to the negative cosine. The cosine of pi over 6 is root 3 over 2. So I'm going to write negative square root 3 over 2. And the y should be the negative sine of pi over 6. And the sine of pi over 6 is 1/2. So I'll write negative 1/2. And lo and behold, look at the symmetry. I got to write that back in black. And look at the symmetry between this and the point above it. These are separated by 30 degrees that way and this way from the negative x-axis. So you'd expect basically the y to be the same magnitude, and they are, but the difference is this one's now next to the y negative part of the y-axis, so you get a negative 1/2. And you also expect, of course, the x-coordinate to be the same completely, and in fact you do get negative root 3 over 2. So that was pi over 6. Now I can do pi over 4. Again, I'm doing pi over 4 just because I can use these special triangles to get pi over 4. I can't use these special triangles to get 5 pi over 6 or 5 pi over 4. So again, I just have a triangle. The cosine of that triangle, of course, is just going to be negative x. If I drew it right here, you can see it. You see the cosine of this angle is adjacent, which is x over hypotenuse, but it's clearly on the negative side, so I'm going to have to add the negative. When I do that, it's easy peasy. Cosine of pi over 4 is root 2 over 2. And of course, I got to make it negative. So this is negative square root 2 over 2. And of course, the y is the same thing. So I got to make it square root 2 over 2 negative again. Now I got another triangle. Again, I can draw it for concreteness. By the way, you could have used these angles if you wanted, but I chose not to. But if you want to go back and do it your own self using this angle, you'll see that you get the exact same result. You just got to remember your sines. So, of course, this angle is now pi over 3. And that's the angle going from here all the way to here. Now, at pi over 3, I just have to use the fact that x is negative cosine theta. And the cosine theta, the cosine of pi over 3 is 1/2. So I'm going to say negative 1/2 for my x. And then the negative of sine of pi over 3 is actually my y. And the sine of pi over 3 is root 3 over 2. So I'll say negative square root 3 over 2. And then at this point, I know the x is actually 0. And the y is actually negative 1. So I'm going to scribble out this mistake that I made earlier. X is going to be 0, y is negative 1. So remember our original statement, y is equal to sine theta, x is equal to cosine theta. So the cosine of 3 pi over 2 is equal to 0. The sine of 3 pi over 2 is equal to -1. Similarly, the cosine of 270 is equal to 0. The sine of 270 is equal to -1. So I've got all that. I just explained all that without y'all seeing. So what I was saying was, since the x is equal to cosine theta and y is equal to sine theta, and since I know this point is 0, -1, that means cosine of 3 pi over 2 is equal to 0, and the sine of 3 pi over 2 is equal to -1, or alternatively, the cosine of 0, or excuse me, the cosine of 270 is equal to 0, and the cosine of, or excuse me, the sine of 3 pi over 2 is equal to -1. So again, all these different points allow me, using these more exact relationships, always gives me my trig functions for graphing. Now I jump back again. This time I've got a triangle that's pi over 6. And when I take the cosine of it, I get the negative of the y. And when I take the sine of it, I get the x. So now I just have to attack it that way. So again, this angle is pi over 6. And my triangle looks like this. And then right there. So looking at this triangle, I see clearly that the sine is going to give me the actual x value, and the cosine is going to give me the negative of the y value. So this coordinate, again, scratching out my mistake I made earlier, the coordinate of this point is going to be, x would be the sine of pi over 6. So the sine of pi over 6 is 1/2. So this should be 1/2, just plain 1/2. Notice I didn't have to add a negative. Almost did anyways, but don't have to. And then, of course, the cosine is going to give me the negative of the y value. Cosine of pi over 6 √3 over 2. So this will be negative √3 over 2, which you should have known because obviously we're next to the negative y-axis. So all these y coordinates all down here are negative. Now I've got the triangle that spreads to pi over 4, like so. So now I'm just using, again, another triangle, a smaller triangle, to work out the details of the unit circle. So this point on the unit circle, again, the sine is given, or the x is given by the sine of the angle being pi over 4, that's √3 over 2, or excuse me, √2 over 2, square root 2 over 2. And then, of course, the y is the negative of the cosine. So the cosine of square root, or 45 degrees, which is, of course, pi over 4, that's just √2 over 2. But, of course, it's got to be negative. So that's that coordinate. And then finally, I got one more angle, which is going to be pi over 3. And that spreads all the way over here. So that's a 60-degree angle. And this triangle, again, I think you can see this triangle has sine returning the x value and has cosine returning the negative of the y value. So again, I write the x value is going to be the sine of pi over 3. And according to my triangle, the sine of pi over 3 is √3 over 2. So it's a square root 3 over 2. And then finally, the y value is going to be a negative. And that's the negative of the cosine of pi over 3, and the cosine of pi over 3 is 1/2. Now notice again, look at the symmetry here. This is exactly the same as that point. This is exactly the same as that point. Notice the differences, more or less just a sign difference. And this is the same as that point, just a sign difference. Same thing here, this point and this point, this point and this point, this point and this point. So these points are all symmetric with each other. Once you've done all this, you automatically know, basically, once you've done these, you can sort of fill out those all by yourself. Now, in this case, x was 0 and y, or excuse me, x was 1. Let's scratch it out. 1 and 0, again, using x equals cosine theta. We know the cosine of 2 pi is 1 and the sine of 2 pi is 0. Similarly, we know the cosine of 360 degrees is 1 and the sine of 360 degrees is 0. So we've now worked out all the points. And if you'd like to compare to a website I found, which you can see the name and the credit and the title, you can see that that's exactly the same results we got. √3 over 2, 1/2, √2 over 2, √2 over 2, 1/2 root 3 over 2. So notice these two are just reversing each other. So I take this one, that becomes that one. I take this one, that becomes that one, like that. So that's one way. Once you get this first quadrant worked out, you've got everything worked out. So I hope that helps you. I hope that makes you understand where the unit circle came from. And now you can actually make out tables of theta versus sine, theta versus cosine, theta versus tangent. Then you can do the cotangents, the secant, and the cosecants, and that actually allows you to graph. And I'm probably going to do that in the next video, which I'll call Trigonometry 004. So let you scan this paper one more time. Again, you can download this document from my Google Docs. All you have to do is email me and I'll give you permission. My email address, and I'm going to put it in video form so it won't be a problem. My email address is billy@physicssolutions.com. So just feel free to email me and reference Trigonometry 003, and I can send you that document. Well, I hope you all enjoyed this. I hope you found it helpful. I'm going to go ahead and kill the video. I'm sorry for about the first 20 seconds of silence or whatever, but anyways, I hope this will help you with your trigonometry class, your pre-calculus class, or whatever it is you're doing. Maybe if you're just learning trigonometry for the heck of it. It actually comes in really handy with building practices and things like that. So have a good day.